So we're going to look at what happens if you don't graph straight lines. So these other functions. So over here, I've got the function y equals x squared, which it looks a bit different to the other ones we did the last lesson. So can you graph other things other than straight lines? Y equals x squared. So what is 0 squared? Well, 0 times 0 is 0. 1 squared is going to be 1 times 1 is 1. Be careful with that one. Lots of people get that one wrong. 2 squared. So we're just substituting these numbers in. 2 squared is 4 and 3 squared is 9. Now, if we look at this doesn't look like a straight line. We may need some other. I wonder what happens over here. So let's add maybe minus 1. Remember, minus 1 squared is 1. So minus 1 times 1 and minus 2. Minus 2 times minus 2 is 4. So what we get here is this sort of graph here. It's called a parabola, and it actually looks like that. So you can graph all sorts of different things as well as straight lines. Here you've got another one. You've got x squared minus x. So we could start with nice simple ones. It's always nice to start with simple ones. 0 squared minus 0 is 0. What about when x equals 1? 1 squared is 1, minus 1 is 0. So that looks a bit weird. We've got a straight line. We've got 2 zeros here. So when x is 2, you get 2 squared is 4, minus 2 is 2. 3 squared is 9, minus 3 is 6. So what you've got, if I can just shrink it a bit, here you go, you've got some points. Maybe we again need to find some minuses. So it's going to be minus 1 squared is 1, minus 1, so that's going to give us 2. So what we've got is, again, this parabola type thing happening. And if we show the graph and collect the points, there is the parabola there. We can have different ones like this where x is in the power or in the indice. Again, it's probably easiest to start with nice simple ones. Why would you start with minus 1? 2 to the power of 0, anything to the power of 0 is 1. 2 to the power of 1 is 2. 2 squared is 4. And if you look at this, here we've got this graph here. 2 to the power of 3 is 8. 2 times 2 is 4 times 2 is 8. 2 is 16. So here you've got one of these graphs that we've been seeing a lot lately. It's called an exponential curve. If you wanted to put this into the calculator, you would find this is 0.5. So again, what we've got is this curve that's increasing very, very quickly. And if we look at the graph, there it is. And, you know, that's the sort of graph that we've got. And as I say, it's called an exponential growth graph. Compound interest works on this sense. There's a few other things that you may have seen this graph around lately, but there it is there. X is on the bottom here. This is another type of graph. So when x equals 6, again, I'm going to pick nice easy numbers. 6 divided by 6 gives us 1. And here it is. X equals 6, y equals 1. What about when x is 3? That's going to give us a nice number. 6 divided by 3 is 2. So we've got there 2. X is 3, y is 2. What about when x is 2? 6 divided by 2 is 3. And when x is 1, x divided by 1 is 6. So what we've got, again, is this, and I'll zoom out a bit. We've got these, which isn't going to be a straight line. If we graph it, this is something we call a hyperbola. So you can graph lots of other things. It's just about substituting into formulas and plotting those points. With straight lines, we might only need 1 or 2 points. With more weirder graphs, we obviously need more points. Thanks.